Hello student, today's topic of discussion is in continuation with the series that we have started in the last video, that is the space physics part 1. So this is space physics part 2. In this we'll be doing astronomical units and the Hubble's constant. First we'll do some common distance units used in this astronomy. So first one is light year. So you must have heard of the term light year. So it is the distance that light travels in 1 year. If you are thinking of how big that distance is, so light year is the unit of distance, first thing. And if you want to imagine how big that distance will be, so one example I'm gonna put, time taken by light coming from sun to earth is approximately 8 minutes 20 seconds. So imagine now same light traveling for 1 year continuously, then how much distance it will cover. So that distance is light year. So very big unit of distance. Now even bigger unit of distance will be the parsec. Okay, so 1 parsec is equivalent to 3.3 light years. Now even bigger is 1 kiloparsec. So 1 kiloparsec, it will be 1000 parsec, that is 3300 light years. So just we have seen 1 light year, how big that distance is. Now imagine 3300 light years, how big that distance will be. Okay, now one more unit we will be saying on this concept, that will be AU. So astronomical unit it is known as. It is the distance between Earth and the Sun. So that is 150 million kilometer. So few questions related with this astronomical unit. First is, how many years does it take light to travel 1 parsec? Okay, first all of you try these questions by yourself, and then we'll discuss the solution also. Second is, our galaxy is about 30 kiloparsec in diameter. What is its diameter in light year? So this is pretty informative. So our galaxy is Milky Way, and they are saying its diameter is 30 kiloparsec, and as you have seen, 1 kiloparsec is equivalent to 3300 light years. So imagine the diameter of our Milky Way galaxy, how big that it is. Okay, now third question is, the distance between the Sun and the Neptune is 30 astronomical unit. So what is the distance in million kilometer? Okay, so all these questions are based on astronomical unit only. So if you want, you can revisit those units and then attempt these questions. Now few more bonus question. Check into these solutions if you have done it correctly or not. Moving on to the next concept. So it's about the Sun. As we have discussed the formation of star in our this previous video. So Sun is one of the medium-sized star, and it consists of hydrogen and helium. Here we have discussed the hydrogen combined together to form this helium, and it byproduct it produces lots of energy. So it emits infrared, visible light, and ultraviolet radiation that all of us knows. So how this nuclear fusion reaction involving? So basic reaction we have given. So if you'll see, it is not as you have seen the hydrogen. So these are what? These are the isotopes, heavier isotope of hydrogen. Hydrogen got 3 isotopes. This is 2 of it. Deuterium and tritium it is known as. As you can see, this atomic number is same, but the mass number is different. Okay, hydrogen has the atomic number 1, and the mass number 1. Second isotope is deuterium, whose atomic number is 1 but the mass number is 2. And in the tritium, whose atomic number is again 1 but the mass number increases by 1, so it is 3. Okay, so when this heavy hydrogen reacting together, deuterium and tritium, then we get helium and neutron. So there is information related with this. Heavy isotopes of hydrogen, deuterium and tritium, react more efficiently with each other, and when they do undergo fusion reaction, they yield more energy per reaction than do two hydrogen nucleus. So the hydrogen nucleus consists of single proton, as the atomic number is 1, and the deuterium nucleus has 1 proton and 1 neutron. Okay, while the tritium has 1 proton and the 2 neutrons, as the mass numbers keeps on increasing. Okay, so that's why those two heavy particles, when fused together, so it will release more heavier neutrons, and so more energy you will get. So the same thing is happening on the sun. So this is about the Hubble's constant. So Hubble constant is the ratio of speed at which the galaxy is moving away from Earth to its distance from. So here the V is the speed at which galaxy is moving away from the Earth. And how it is formed? So it is formed using the redshift. That more discussion about this redshift will come on the later part of this video. And D is the distance of faraway galaxies and is formed using the brightness of supernova in that galaxy. Okay, so this is velocity with which galaxy is moving, and this is the distance. Okay, so the ratio will come to 2.2 in 10 power minus 18 per second. So look to the unit. So it is coming per second. How? The velocity unit will be meter per second. Okay, and this is a distance, its unit will be meter. So when these two get cancelled, so it will be per second. And if you'll try to connect it with, so frequency unit is also per second, because it is 1 upon time period. Okay, so its unit is also per second, second inverse. We can say this is equivalent to that unit of frequency. So if we inverse this frequency thing, if you write this as 1 upon f, so it will be equal to this time period. Okay, so this 1 upon h naught, this Hubble's constant, will be distance upon velocity, the reverse of this thing. So it's represent age of universe. Age of universe. So from this Big Bang theory, when it happened, to now, the time lapse. So this will answer how old our universe is. So the question is graph based. The graph below shows how the velocity of galaxies moving away from Earth. So this velocity is known as recession velocity. This is also one information. Depend on their distance away from us in the light year. So on x-axis we have taken the distance in light year, and along the y-axis we have taken this recession velocity. According to Sir Edwin Hubble, the theory is the recession velocity of galaxy is directly proportional to its distance from the Earth. That we can see using this graph. This graph is of directly proportional. Okay, so the distance is directly proportional to this velocity. So what the question is, state how the graph supports this Hubble's theory. How this graph is supporting this Hubble's theory. So as we have seen in Hubble's theory, the velocity, recession velocity, was directly proportional to the distance that was in the light year. So if you look to the graph, it was a directly proportional graph. No, this on this axis there is a velocity, and this axis there is the distance, and this is the slope. Okay, so if you try to plot the parallel line along the y-axis and parallel line along the x-axis, it is directly proportional to this. So it shows, it validates the Hubble's theory. Okay, moving on to the next question. The gradient or steepness, this slope thing, this theta, the angle that this line makes with the x-axis is known as slope or gradient or steepness. Okay, so gradient of the graph is called the Hubble's constant, that h naught. Okay, we have seen this h naught in the just previous slide, that it is v upon d. So this thing, y-axis upon x-axis. So y upon x will give you what? Slope or gradient. So what the question is, gradient or steepness of the graph is called the Hubble's constant. Its value is given by Hubble's constant is 1 upon the age of universe that we have seen. So explain how the gradient of this line will change in future. So in future, how the slope will be changing. So as we've seen, this h naught that in the question they are saying is 1 upon the age of the universe, as this will increase with the time. So obviously this will decrease because they are inversely proportional. So if this will be decreasing, so gradient will be decreasing. So explain how the gradient of this line will change. So gradient will decrease. Moving on to the next question. The speed of recession of the distant galaxies is measured at 600 km per second. Use the graph to calculate the distance of this galaxy from the Earth, and the value for 1 light year they have given you. Okay, so for that we have to look into the graph. Here is the this velocity that is given in the question, 6000 km per second. So if you plot this, it is coming here. Okay, so 4 into 10 power 8 light year, and the value of 1 light year is given. So now look to the solution part. All these solutions is given or there, you can refer from here also, and we already have this discussed those questions. The question is, explain what is meant by the term cosmological redshift and how it provides the evidence for the origin of the universe. So in the cosmological redshift, what happens? The wavelength at which the radiation is originally emitted is lengthened as it's traveled through the expanding space. So this wavelength is keep on expanding, keep on increasing in length. Okay, so cosmological redshift results from the expansion of the space itself and not from the motion of individual body, because everything is expanding, everything is moving with a great velocity. So compare a galaxy from a long time ago with a galaxy from more recently. Okay, so although each galaxy emits the same wavelength of the light, and the light from the older galaxy has spent longer traveling through the expanding universe, so obviously its wavelength will be more than the newly formed galaxies. So that stretching thing is a redshift. The universe must have originated from a singularity formed by a big bang and has been expanding ever since. Hope you have understood that concept. So what it is cosmic microwave background radiation. So CMBR is a microwave radiation of a specific frequency that is observed in any point in space. So it was produced shortly after the universe was formed with a much shorter wavelength. So keep this in mind. When it was formed, its wavelength was very small, and gradually it keeps on increasing. This radiation expanded into the microwave region of the spectrum as the universe expanded. That's why it is known as cosmic microwave. So a few more concepts are coming up in the coming video. So all of you stay tuned for that thing, and hope you're enjoying these concepts. Keep on giving the feedback related with these concepts. Thanks a lot.